Good morning students. What else in the previous session? In the previous session we had discussed what is the radioactivity, definition of radioactivity, and who discovered the radioactivity, and who radio scientists will be analyze the radioactivity process, and then units of radioactivity. What are the difference between types of natural and artificial radioactivity, and then what are the difference between the types of radioactivity, that all are discussed in the previous session. Okay. In the today's session I will explain alpha, beta, gamma radiations and their decay process also. Alpha, beta, gamma radiations. Alpha, beta, gamma radiation, that all are emitted in the radioactive reactions. So one radioactive element, it will be undergoes a decay process, that it will be emit some radiations. That the radiations is very harmful and having names also, that are called as alpha, beta, gamma radiations. All the radiations will be having individual properties. Okay, all the radiation, it will be degayed from the radioactive element to produce the parent daughter nucleus also. So first I will explain that what are the properties of alpha, beta, gamma radiation, and then decay process also. Okay, so first alpha, beta, gamma radiation, already I told alpha, beta, gamma radiations all are emitted during the nuclear radiation process. Nuclear radioactive element undergoes a fission or any process that will be definitely emit some radiations. That radiations will be called as alpha, beta, gamma radiations, and some other radiations also it will be emitted, but that three is very basic radiations. Okay, and then very harmful also. Then alpha, beta, gamma radiations. So first, what are the properties of alpha, what are the properties of beta, what are the properties of gamma? This is a very important detail in this lesson, so you have to learn thoroughly and then listen carefully also. So first, what is alpha, what is beta, what is gamma? What are they? What is alpha particle, what is beta particle, what is gamma particle? Alpha particle, helium nucleus, it will be called as alpha particle. Alpha is helium nucleus. So helium symbol is helium 2, 4. 2 is, already you learn in 9th standard or any in the lower classes. 2 is atomic number, 4 is mass number. Helium 2, 4. This is the alpha particle and having 2 protons and 2 neutrons. 2 protons and 2 neutrons. 2 protons and 2 neutrons. And this is beta particle is called as electrons. Electrons, atomic number -1 and mass number is 0. Okay, so having electrons only. Then gamma particle will be called as electromagnetic waves. Electromagnetic waves will be always shows the light. Light is always having the photons. So simply is mentioned with alpha is helium, beta is electron, and gamma is photon. Okay, are electromagnetic waves. So first, alpha it will be helium, it will be called as alpha particle, electron it will be called as beta particle, and electromagnetic waves it will be called as gamma particle, and photons it will be called as a gamma particle. Okay, and then what is the charge of alpha particle, what is the charge of beta particle, what is the charge of gamma particle? Charge means having some electron movement. That the electron movement, normally alpha particle will be called as it will be have a positive charge and 2 positive charges. So that is plus 2e. So alpha particles always have a positive charge, and beta particle will always have a negative charge. It will be mentioned with -e. Okay, but gamma particle it will be having a neutral charge. Neutral charge means nor positive charge nor positive charging கிடையாது, negative charging கிடையாது. It will be having the neutral charge particle. So the charge is 0. So alpha is positive charge, beta is negative charge, and gamma is neutral charge. Charge of the alpha is plus 2e, charge of beta is -e, and charge of gamma is 0. Okay, and that are 2 points. And then ionizing power. What is mean by ionization? Ionization means one atom, it will be fused with another one atom. First atom having some atomic number, second atom is having some atomic number, and outermost layer of the outermost orbit of the first atom having electrons is lower than that of 8. It will be ready to share the electrons to the nearby atom to produce a new radioactive element or to produce a new atom. ஒரு atom இன்னொரு atom ஓட bombard ஆகும்போது it will be sharing of electrons to the nearby one. that the sharing of electrons, it will be converted into positive ion and negative ion, that will be called as ionization. So one element, it will be lose some electrons to form a new ion. So losing of electron atom, it will be called as positive ion. Gaining of electrons from the nearby atom, it will be called as negative ion. So sharing of electrons only decide the positive ion and negative ion, that it will be called as positive ion, negative ion preparation, it will be called as ionization. So the ionizing power, it will be different from alpha, beta, gamma. So ionizing power, ionization power of the alpha, completely it will be 100 times greater than that of beta, and 10,000 times it will be greater than that of gamma. So it will be alpha, it will be having high ionization power. Alpha, it will be always having high ionizing power, and beta, comparatively alpha, it will be low, and then gamma, very low ionization power. So ionizing power is nothing but a sharing of electrons to form ions, positive ion and negative ion. So positive ion, negative ion formation by ionization process. There the ionization process, ionizing power, it will be 100 times greater than the beta, and 10,000 times it will be greater than gamma, and comparatively low ionization power, very low ionization power. And then penetrating power. Penetrating power means which particle it will be easily move to the one particle, or easily move inside of the one particle, that will be called as penetrating power. That the penetrating power of alpha very low, and penetration power of beta, it will be comparable greater than that of the alpha rays, and then very high ionization, and gamma particles are having very high penetrating power is comparable alpha and beta rays. Okay, so ionization power and penetrating power, it will be inverse with one another. So alpha particle having high ionization power, and alpha particle having low penetrating power, and then gamma particles are having very low ionization power, and gamma particle are having very high penetrating power. So it will be inverse with one another. Okay, it will be ulta of one another. Okay, then electric field and magnetic field. Alpha rays deflected by the electric field and magnetic field. Alpha particles are moving from one point to another point. Some electric field is there, definitely it will be deflected. And then suppose you have to fix the thick metal block in the way of alpha rays, in the path of alpha rays, that the alpha rays will be definitely deflected and then change the direction. That will be called as deflected by electric field and magnetic field. Alpha rays must deflected by electric field and magnetic field, and then beta rays, it will be deflected, and then the direction of deflection, it will be opposite the that of alpha rays. So direction of deflection, it will be opposite direction of the alpha rays movement. Okay, so alpha rays and beta rays, that two rays, it will be definitely deflected by the electric field and magnetic field, but one direction, it will be opposite the another one direction. And gamma rays not deflected by the electric field and magnetic field. So alpha rays, it will be deflected by the magnetic field, and beta rays also deflected by the electric field and magnetic field, but gamma rays not deflected by the electric field and magnetic field. Clear ma? And then speed of alpha ray, speed of a beta ray, and speed of a gamma ray. The speed of the alpha, beta, gamma radiation, it will be compared with the speed of light. Okay, what's the value of speed of the light ma? 3 into 10 power 8 meter per second. Okay, 3 into 10 power 8 meter per second. That is the speed of a light in air. So the speed, compared with the speed of the alpha particle with the speed of a light, 1 by 10 to 1 by 20 times the speed of the light. Having alpha having a speed 1 by 10 to 1 by 20 times of speed of the light. Then 9 by 10 times of the speed of the light, that will be beta. And then gamma rays is always travel with the speed of light. So that all are the properties for alpha, beta, gamma radiations. Okay. So first, alpha means helium, beta means electron, gamma means electromagnetic waves. So alpha, 2 protons and 2 neutrons is there, and beta particles, electrons is there, gamma particles, photon is there. Okay, consisting of photons. Alpha particles having 2 protons and 2 neutrons, protons having electrons, and gamma particles is consisting of photons. Okay. Then second one, charge of the alpha is positive, charge of the beta is negative, charge of the gamma is neutral. Then charge value is plus 2e for alpha, minus e for beta and 0 for gamma. Then ionizing power, so alpha 100 times is greater than the ionizing power is comparable to beta, 10 times is greater than the gamma, and then beta rays is having ionization power is low and gamma rays will be having very low ionization power. And penetrating power for alpha rays is very low and penetrating power for beta rays will be greater than that of the alpha rays, and then gamma rays will be having high penetrating power, and then it will be very much greater than the alpha rays. So that the penetration power, it will be trigger the mutation of mutations of the human gene, and then mutation of human gene, and then to form an gene formations, irregular formation, it will be produced in human bodies. Okay, electric field and magnetic field. So alpha rays is definitely deflected by electric field and magnetic field, and beta rays it will be definitely deflected, it will be opposite to that of the alpha rays, and gamma rays not to be deflected from the electric and magnetic fields. And then speed of the alpha is 1 by 10 to 1 by 20 times the speed of the light, and speed of the beta 9 by 10 times the speed of the light, and gamma is they travel with the speed of the light. That all are the properties of alpha, beta, gamma radiations. Okay, and then next I will go for decay process. Decay process means alpha, beta, gamma. Before enter the decay process, first I explain radioactive displacement law. Radioactive displacement law, it will be framed by Soddy and Bajan in the year of 1931. Okay, Soddy and Bajan will be two scientists. It will be framed the one law, radio disintegration law, radio displacement law, radioactive displacement law. Two law, it will be the same. That law tells one radioactive element, it will be Decay. Decay means emit some alpha particle or emit some electrons or emit some gamma rays. It will be easily to form the new radioactive element. So during the decay process, definitely it will be release some alpha or electron or neutron or gamma rays. Okay, then that the decay process will be classified into two: alpha decay, beta decay, and gamma decay. First, I explain alpha decay. Alpha decay means alpha particle will be emitted from the parent nucleus. So we have to design one parent nucleus. We have to consider one parent nucleus, that is uranium 92-238. 92 is the atomic number and 238 is the mass number. Okay, how will you mention the atomic number and mass number? Atomic number is always mentioned with Z and mass number is always mentioned with A. And number of neutrons in the radioactive element is A minus Z. So N is equal to, capital N is equal to A minus Z. This is already you learned in 9th standard. Okay, X, Z, A. Okay, A is mass number, Z is atomic number, number of neutron is equal to A minus Z. This is the radioactive element. So now this alpha decay process, we take uranium 92 and 238, it will be undergo the nuclear reaction, it will be undergo the nuclear fission. Uranium it will be turns into thorium 90 and 235 plus it will be emit one alpha particle. So alpha decay process, definitely that the radioactive element will be emit the alpha helium to change into the daughter nucleus. So parent nucleus will be changed into daughter nucleus with emission of helium. Helium is the alpha particle. So that the process will be called as alpha decay. So uranium, it will be released the daughter nucleus, that the daughter nucleus is thorium 90 and 234 plus release some helium particle also, that the helium particle will be called as alpha particle. So that the process will be decay the alpha to change into the new radioactive element, that will be called as alpha decay process. In the alpha decay process, the daughter nucleus daughter nucleus is having the atomic number and mass number comparable to the parent nucleus. This is parent nucleus, this is daughter nucleus. So parent nucleus it will be decreasing, atomic number is decreases by 4 and mass number it will be decreases by 4 and atomic number is decreases by 2 to to form the new radioactive element, because helium atomic number is 2 and mass number is 4. So in the daughter nucleus, 4 mass number it will be decreases and 2 atomic number it will be decreases to form the alpha decay. Okay, alpha decay process la create agadiya daughter nucleus la 2 mass number on the decrease 2 atomic number it will be decreases and 4 mass number it will be decreases to form the daughter nucleus. Okay, then in the decay process, beta decay process, that the radioactive element it will be degays to convert into daughter nucleus with the emission of electrons. So the electrons will be mentioned with -1 e power 0, -1 e power 0. Okay, this is the electron. During the beta decay, the paranucleus emits some electrons. That why it will be create some new radioactive element. So phosphorus 1532 it will be converted into sulfur 1632 plus electron. So mass number does not change because 0 is in the upper limit. So the upper limit is 0, so no mass changes because 32 is there in the left hand side also. Mass number 32 in the left hand side also, in the right hand side also. But atomic number is only, it will be increases with 1. So atomic number increases by 1, mass number does not change. That will be converted as a new radioactive element. So in the beta decay process, one radioactive element it will be decayed to form the new radioactive element with emission of electrons. So mass number no change and atomic number is increases by 1 because -1 e power 0. இங்க -1 இருக்கறனால இங்க வந்து நம்ம என்ன செய்றோம், 1 ஆட் பண்ணிக்கிறோம். Okay, so 16s32. So atomic number, mass number does not change. Okay, this 32 and 32. But we have to compare with the atomic number of paranucleus and daughter nucleus. Left hand side 15 is there, right hand side 16 is there, so increases by 1. That only the emission of, that will be indicates the emission of electrons in the beta decay process. Okay, and then gamma decay process, no atomic number, no mass number change, it will be remain same. Okay, but energy level means it will be one electrons will be jumped from one level to another level, that the energy level only change, not atomic number and mass number does not change, it will be remain same. So that is the 3 decay process: alpha, beta, gamma decay. So alpha decay emits some helium, beta decay process emits some electrons. In the gamma decay process, energy level only change, not atomic number, mass number does not change, and then it will be remains the same. Okay, clear? So this is the alpha decay process, alpha beta particle properties and then decay process. Now I explain the fissionable and fissile material or fertile material. Fissionable material or fissile material and fertile material. What is the meaning that fissionable material? Which radioactive element it will be participating, it will be involved in nuclear fission process. Next video I will explain what is nuclear fission and nuclear fusion. So now I explain fissionable or fissile material or fertile material. Okay, fissionable material means one radioactive element it will be participate in nuclear fission process or it will be undergoes the nuclear fission process, that it will be called as fissionable material or fissile material. But in the fertile material means one fissionable material it will be converted into non-fissionable material, it will be converted into fissionable material, that the material it will be called as fertile material. Which fissionable, non-fissionable material is easily converted into fissionable material, that the non-fissionable material it will be called as fertile material. All the non-fissionable material cannot be easily changed, it will be easily transformed, but some non-fissionable material it will be easily converted into fissionable material, that the non-fissionable material it will be called as fertile material. Some examples over there. First, fissionable material. Fissionable material it will be also called as fissile material also. Okay, uranium 235, plutonium 239 and plutonium 241, that all are the fissionable materials. So easily is undergoes a nuclear fission. Okay, easily participate, easily involves in nuclear fission reactions. But uranium, normally natural uraniums are having uranium 238 and uranium 235. In the percentage of 99.28% uranium 238 element is there, and 0.72 percentage is uranium 235 is there. So one natural uranium having the two uranium constitution particles, that the uranium is 1 uranium 238 in the percentage 99.28 percentage, and another one is uranium 235.72 percentage. Okay, that the ratio, that the percentage ratio, it will be comparable. Uranium 238 235 very low, but uranium 235 only fissionable material, fissile material. Uranium 238 is a non-fissionable material, but that it will be considered as a fertile material. So it will be easily converted into fissionable material. So that the uranium 238, it will be considered as fertile material. Okay, fertile uranium 238 also fertile material, and thorium 232 is a fertile material, and plutonium 240 is a fertile material. So that is a fissionable and not fissionable kadiyadu, that is a fertile material, a fissile material or a fertile material. So I can remind all the points. Okay, recall all the points. So first in this session I explained alpha, beta, gamma properties and radioactive displacement law are 3 Decay process. First I explained the properties of alpha, beta, gamma radiations. So that the radiations should be emitted from one radioactive process or one radioactive reactions. One radioactive element, it will be bombarded with any one helium or anything, it will be easily decay some radiations. That the radiations will be called as alpha, beta, gamma radiations. The alpha, beta, gamma radiations are having some unique properties. So properties of alpha, properties of beta, properties of gamma. Okay, so properties of alpha, first what is helium, sorry, what is alpha, what is beta, what is gamma? Helium it will be called as alpha, and electron it will be called as beta, and gamma means electromagnetic waves is will be called as gamma. And then alpha particles is having 2 protons and 2 neutrons, and beta particle will be consisting of 2 electrons, gamma particle consisting of photons. Okay, then charge of alpha is positive, charge of beta is negative, charge of gamma is neutral, and then value of the charge for alpha particle is plus 2e, and value of the charge of beta rays is minus e, and value of charge of gamma rays is 0. Okay, then ionizing power of the alpha, it will be 100 times greater than that of the beta rays, 10,000 times it will be greater than the gamma rays, and then comparable to the alpha rays, beta rays is having low ionizing power, but gamma rays is having very low ionizing power. Then penetrating power of alpha rays it will be low, penetrating power of beta rays it will be greater than that of the alpha rays, and penetrating power of the gamma rays is having very high penetrating power, and it will be greater than that of the alpha rays. Okay, comparable to the gamma, for ionizing power and penetrating power, ionization power of the gamma is very low, but penetrating power of the gamma is very high. Okay, it will be inverse of one to another. Then electric field and magnetic field. Alpha rays definitely will be deflected by electric field and magnetic field. Suppose you have to fix one metal blocks in the on the way of alpha rays, it will be definitely be deflected, that will be moves in a different direction. So alpha rays definitely will be deflected by electric field and magnetic field, but beta rays it will be deflected by the electric field and magnetic field, but the direction of deflection it will be opposite to that of the direction of alpha rays. So alpha rays ko oppositely it will be moved, and then gamma rays it will be not deflected by the electric field and magnetic field. Gamma rays it will be not deflected by the electric field and magnetic field, and then speed of the alpha rays is 1 by 10 to 1 by 20 times of speed of the light, and beta rays is 9 by 10 times the speed of the light, and then gamma rays they travel with the speed of the light. What is the value of speed of the light, ma? 3 into 10 power 8 meter per second. Okay, then next I will explain decay process. Decay process, radioactive displacement law it will be given by the scientists Soddy and Bajans. Okay, Soddy and Bajans, Soddy and Bajan, and then the two scientists will be given the decay process for alpha, beta, gamma. one radioactive element, it will be decay the alpha to convert a new daughter nucleus, and one beta in during the beta decay process, it will emit some electrons to produce the daughter nucleus. In the gamma decay process, no electrons, most probably the atomic number and mass number of the daughter nucleus will be remains same, energy level only change. During the alpha decay process, I will give one example for that. Uranium is a radioactive element, it will be emits to produce the daughter nucleus and emits some helium. That the helium is alpha particle. So, in the reactive reaction process, helium it will be emitted. So, that the alpha particle it will be emitted, it will be called as alpha decay, and electrons it will be emitted, it will be called as beta decay. So, in the beta decay process, phosphorus it will be produce the daughter nucleus, that it will be sulfur, and release some electrons. That the process will be called as beta decay, because electrons will be emitted, it will be called as beta decay. That the time mass number no change, but atomic number is increases by 1. That the alpha decay process, atomic number is decreases by 2, and mass number is decreases by 4. And then gamma decay process, energy level only change, no atomic number, no mass number change. So, it will be remains constant. Okay. Then next one is fissionable and fertile material. Fissionable means which radioactive element it will be involved in the nuclear fission process, that will be called as fissionable material or fissile material. For example, uranium-235, plutonium-239 and plutonium-241, that all are the fissionable materials or fissile materials. So, I will give one example for that fissionable material. Fissionable, normally natural uraniums is having uranium-238 and uranium-235. That it will be in a percentage ratio, 99.28% is uranium-238, 0.72% is uranium-235. That the two components, one is it will be easily involved in fission reaction, that will be called as uranium-235 is a fissionable material, but uranium-238 is non-fissionable material. That the non-fissionable material is easily converted into fissionable material. So, that the fissionable material will be called as fertile material. Okay. So, which non-fissionable material will be easily converted into fissionable material, that the non-fissionable material will be called as fertile material. So, for example, for that fertile material, uranium, thorium and plutonium, uranium-238 and thorium-232 and plutonium-240. Okay. So, these all are the topics I discussed in the today's session. So, one is properties of alpha, beta, gamma radiations and radioactive displacement law. It will be given by the Soddy and Bhajan in the year of 1931, and 3 decay process alpha, beta, gamma, and I explain the types of materials, that is fissionable and fertile materials, and some example for that fissionable and fertile materials. Okay. That all are discussed in the today's session. And a home assignment for today's session is, home assignment for today's session, home assignment, learn and write second detail in unit 6. Okay. Learn and write the second detail in unit 6. Clear ma? So, second detail is properties of alpha, beta, gamma radiation. So, you have to learn and then make a tabular column to difference the properties of alpha, beta, gamma radiation. Not to be write in paragraph format. It will be mentioned with a tabular form. Okay. So, learn and write second detail in unit 6. Okay. Thank you.